For this example, I'm going to mostly focus on parts C and E. However, I will touch on the other parts of this problem as each part kind of builds onto the next, or builds to the next. So in this example, we're told that there are a certain number of traffic fatalities in the United States, and of those, this number, 9,001, were alcohol related. So what we're seeing here, the 9,001, is that event that most of these probabilities in here focus on out of a total number of traffic fatalities over here. And so that was done correctly in this particular part for parts A and B as far as finding the probability that a randomly selected fatality is alcohol related or not. So here and here. The difference in part C is that now you're looking at 2 randomly selected traffic fatalities in 1 year. So what I want to do is go back to the e-text, which you do go through this e-text through your assignments. And this particular lesson comes from section 5.3 on independence and the multiplication rule. Now, when we open that e-text, you would want to forward through Objective 3 and go to the next to last page in Objective 3. And this is where we see a summary of probability rules that we will need for our course from Chapter 5. So here, the first 3 rules aren't really related to what we're looking at in our problem, but what we do see, this last rule, if E and F are independent events, then the probability that E and F occur is the probability of E times the probability of F. Now, how we can apply that to this problem is that we really have 2 alcohol-related probabilities in part C. In other words, it's like saying the probability that one fatality is alcohol-related and the probability that another fatality is alcohol related. Okay, so what we do then, according to that, back over here, back to that rule, is we take the probability of each event and we multiply them together. So in other words, I now come back to part A. This was the probability that a fatality is alcohol related. I'm going to multiply that by the probability the fatality was alcohol related. All right, so whenever I do that on my calculator, it can look like this because I'm multiplying that probability by itself, or even as a shortcut, because you are multiplying that probability by itself, you could square it and end up with this. So either way, once we round to 3 decimal places, we get the same value that we're looking for here in part C. In part D, you were asked the probability that neither fatality was alcohol related. And notice that's the same thing as doing the probability that no alcohol times the probability of no alcohol. In other words, this number, 0.698 times itself, gives you this probability because you're looking at 2 events, 2 independent events. All right, so now I say that because I need that to answer part E, that the probability that at least one fatality was alcohol related. Coming back to the e-text, over here, I'm going to move up now to rule number 5. If E represents any event and E of C, and that's the complement, represents the complement of E, then the probability of the complement of E is 1 minus the probability of E. So here, the complement of neither fatality was alcohol related is that at least one fatality was alcohol related. Those 2 are complements of each other. So I'm going to use that fact to say 1 minus the probability that we had here in part D to get the probability that we're looking for here in part E.